Welcome to this tutorial on using FastAPI with HTMX and Ollama. You'll first need to install Ollama. Go to ollama.com and download the Ollama for your specific version. I'll be doing the tutorial on a MacBook Air with 16 megabytes of RAM. It's an M1. The tutorial focuses on Llama 3.2. This is a much smaller LLM than what you would get from something like ChatGPT. However, it is suitable for our test using HTMX. The focus of the tutorial is on the UI and getting the stream working with HTMX. Once you have Llama 3.2 installed, you should be able to call it from the API endpoint. Ollama should download the version of the LLM that is optimized for your specific platform. In my case, I'm using the GPU that's integrated with the MacBook Air M1. The process is largely the same on Linux, and I have installed it on Linux as well, Ubuntu 24.04. If you're using a different LLM, that's fine. You just need to change the name of the LLM in the Python script that I'll be walking you through. If you want to use the same version of the LLM that I'm using, just go to the ollama.com site in the library, look for Llama 3.2 latest, and that's the latest that I'm using as of July 2025. I'm using the 3B model. As the focus of the tutorial is on just the UI for the LLM, you can just use a small LLM and it should be fine. I'm using the Python virtual environment, VENV, for this tutorial. Once you've set it up, you activate the virtual environment with source VNV bin activate. You need to install some dependencies for Python, pip install FastAPI, and we're going to use a version of FastAPI package that is called standard. This will install additional mod programs that you need, such as UVcorn. And then I have a space after the FastAPI. We're going to install SSE underscore starlet. I'm going to use Cursor, which is basically the same as VS Code. I have the tab completions on Cursor turned off for the tutorial, and I suggest you do the same thing. This is the third tutorial in the series for HTMX. So I start the file name with a 3. That's just so I can know which tutorial that I'm working on. And before we get started, I think I'll install pip install async.io, which we're going to use for some of the asynchronous waits. Okay, we have a blank screen, and I'll actually open up the folder within Cursor for the directory that the project is in, because we're going to need to access the templates subfolder shortly. Okay, the first step is to import FastAPI with a capital F, and the API is capitalized. Once that's imported, we can instantiate the FastAPI class. Now we can use that app to interact with FastAPI. So the decorator app.get, there's an @ sign in front of it. We're going to get the home route or the root route of the application. Let's just call it home by convention. And we'll have it return a string. This will be in JSON at the current time. FastAPI is primarily used as an API server, and it's great for that. However, for this tutorial, we're using the ability to serve up HTML, which we'll get into shortly. We're just serving up the JSON as an initial test. So I'll prep the HTML file. We're not going to use it for this next short little test here. but we'll use it after we make sure the server is working. Okay, we got an HTML file. We haven't connected to the HTML file yet, but first let's check out whether the server itself is working. We need to run the application with something called UVcorn. That's UVI. There's another very similar sounding application called Unicorn. That's not the one we're using. And the syntax to run UVcorn with the V is UVcorn space. You have the name of the file without the .py. The name of our file is 3_LLM_connect. You have a colon, and then you have the word app. Then we have reload. The word app is the variable in your Python file that you instantiated the FastAPI class with. By default, UVcorn will start up a localhost on 8000. And we have the string coming through as JSON. You can test it with the browser. Now that we have the server working, we're next going to return the HTML from the templates directory and the HTML file that we created. In order to do this, we need to import request on line 1. There's a request with a capital R. The Jinja2 templates on line 3. And we're not using SSE_starlet right now, but we will use it shortly. So since I'm working on the imports, also import the event source response from SSE_starlet. So the default route, home, we defined it the asynchronous method here. It's going to have to receive the request over the network. The variable name is request. After the colon is the request, which is the data type. That second request is on line 1. That's the name of the class that we have imported. Right now on line 11, the templates actually is a variable that I need to create from the Jinja2 templates. And right now it doesn't exist, which is why there's an error in the linter. However, I know what to write, so I'm going to assume that I'll create the templates variable later from an instantiation of Jinja2 templates, and I'll create this .templates response from the Jinja2 templates, and we will pass it the file plus the request. Okay, we have it set up, but we still need to instantiate the Jinja2 templates and assign it to the variable template. So let's drop it down below where we instantiate the FastAPI, that app. Templates, this is the variable that we're creating, right? And then we're going to instantiate Jinja2 templates, pass it the directory that we created. So this templates name, the second one in the directory equals templates. That's the name of the folder that we created. With the web page working, it's getting it from the template file now. We can just add a little bit of decoration onto the HTML document. So I'll put the H1 heading within the body. And we'll create a div here that we'll use in the future with the HTMX and the SSE, or HTMX SSE, server sent events. So we'll use that div in the future. And right now, it looks good. All right, we have one route working. That's the home page, and that default home route is returning HTML page. We're going to create a second route to eventually talk to the AI, and that will serve as a route that will just serve up data. So it's not going to return any type of HTML, but it's going to look very similar to the HTML route that we have. So the syntax is the same, @app.get, and then you have a /AI. That's going to be the route. So instead of just slash at the end, :8000, we'll do :8000/AI. That's how we're going to access the data. Within the first method, the async def AI, we're going to create another method here to handle the stream portion. And that new method, event_stream, that's something that we're creating, right? We're defining it as event_stream. It's going to use the keyword yield, and yield is a special word that prints something to the stream. So add it to the stream. We're going to use a syntax here, curly bracket, event, which is a special word, status, and data is also a special word here. This syntax is because we're using SSE _ starlet. It's a little different than maybe some other implementations that's using the raw SSE syntax. But this is easier to read and less prone to error. So we'll set the event as a message, and the data will be very simple starting event stream. Then we will return this as a test. And we're going to return event source response. The event source response is from SSE _ starlet. This is a pre-made package for you that will handle some of the protocol that's being sent to the web page as a SSE, server sent event. So at the current time, the message that we're sending over is not appearing on the web page, although it will appear on the direct endpoint at /AI. So that /AI endpoint is working. The data is getting sent to the web page, but we have no way to display the data from the SSE server sent event onto the web page. In order to display the data onto the web page, we're going to use something called HTMX. This is a JavaScript library that makes it easy to add interactivity onto HTML pages. It's an alternative to using JavaScript to write your logic. Go to htmx.org. We're going to use a CDN to install two different libraries. One's an extension, and the other one is the main HTMX library. So this is right here on the front page. Look for the quick start section, and you can see the actual CDN script endpoint. I'll also put this on the GitHub repository, which I'll place in the link in the description of the video. And I'll have the that little script tag, which you need to drop into the HTML file and put that script in the head section of the HTML file. HTMX is pretty powerful with a lot of different packages and different functionality. In the docs section, we're going to check out this WebSockets and SSE. You could read about it here, and it's probably good to read the documentation. However, right at the top of that page, there's a link to the SSE extension that we're going to want to install. So you could read it now, or you could just do the installation, and after you get it working, then go back and read the documentation. Just to make it a little easier for you to find the section that I'm talking about the extension, I put the URL right there so it's easier to see. It's extensions/SSE/. So on that page, the second script is the one that we're going to need to use the SSE extension. And I'll just drop it down here, and I'll put it up on GitHub so you can find it easily if you can't find it on the web page. well, I'm going to delete the integrity value here. I had some problems with it in a previous video. I haven't found out the source of the problem yet, but I think for the purpose of the tutorial, I'm just going to delete the integrity key. Then below that first script, drop the extension SSE. Note that I'm on version 2 of HTMX, and the SSE extension is also version 2.2. All right, we're getting to the exciting part of the tutorial. This is the part we're using HTMX and SSE. Notice in the div tag, I'm writing inside of that last greater than sign, so the closing portion of that first div tag. We're specifying the extension to use for HTMX, which is SSE, and that's in that JavaScript on line 8. And then for the SSE connect, we're specifying on line 16 of the Python program the route/AI. That's how your HTML is connected over to the Python program and be able to pull the data from that /AI. For the SSE swap, we're going to be passing a message and a status from the Python program into this HTML program. So we're going to specify that message and status in Python. We'll close the stream, and we're going to specify it as close. So I just want to set up the HTML now, reference the HTML when we do build that Python portion of the program. Currently, it is working, right? We have the starting event stream, which you should see in the web browser. It's happening so fast that you might forget that there was actually a piece of text there ahead of us sending the yield, putting that, basically printing over into the stream. So I'm going to set up a sleep event, because I'm using async io.sleep, I need to import it first, because this, remember this method is async method, right? So now it's more obvious that we are starting with the text message that we have in the HTML, and it's being replaced without refreshing the screen with the data that's being sent from the async method. So if you recall that I'll connect to the LLM is hard-coded into your HTML. We're using the HTMX to replace the value of that div with the value that's coming in from that yield statement. And we're using the async io.sleep as a, just to slow it down so that we can see it more clearly. So we're going to try to connect to the local Ollama LLM. We're not going to use the Ollama SDK, which does exist for Python, but in order to make it more obvious what we're doing, we're going to set up a simple HTTP request asynchronous with the HTTPX package. This is a replacement for the popular Python request package, and it has the async client on that HTTPX package. The with keyword is a special keyword from Python, and is useful for the setup and cleanup code of the connection. We have a new user-defined variable, resp, which is response, and then we're going to await, because it's async, the client, which is the async client, and the line above it. It's a post request to the endpoint of Ollama. For the tutorial, we're using the simpler API/generate, not the chat API endpoint of Ollama. If you're writing for OpenAI, I believe they only have the chat API endpoint nowadays. The API generate is simpler and it has most of the same concepts or functionality to illustrate here. So the name of the model, that Llama 3.2 has to be the same name on your computer. On line 25, make sure when you do Ollama list that is the same name. I've had problems with the Phi model. Mistral and Quen also work quite good, but may require more resources. To help with the debugging and to illustrate what's happening, I'm going to first print the HTTP status code. Hopefully we'll get a nice 200, which means OK. And I'll also put it to the stream. But first, this will be printed to the console where you start the UV-corn. And we're using the F string in Python. So the thing in the curly brackets can be a Python variable. It's getting the response.status code. The response again from HTTPX. The yield is printing it to the stream. So we have a special syntax that is specific to SSE underscore starlet, where we have the curly brackets, the event, the colon, the status, the comma. Then data is another keyword. If you refer back to the HTML, remember that the status is in the swap. I'm just putting the async await in here so that we have a more visual example. The whole purpose is to show that the messages from the server are being sent to the web page, and the web page is not being refreshed, right? I mean, it's being refreshed, but it's not being reloaded. And that the real benefit of the HTMX is to have minimal JavaScript to make it easier to read and work with in the web page, and focus on the Python programming, assuming that you're proficient with Python. And it's pretty popular nowadays to use Python for AI or LLM programming. So we'll put the response.text, right? So that's a property of the response which we're getting back from the HTTPX request, async request. And we're going to print out to the console as well as yield it, so print it over into the stream. It's going to be sent to the web page as a stream, and the SSE will be able to pull out the event message and the data. So it's pretty cool that you can have kind of minimal code both on the server and in your web page, and have the pretty good experience with the connection stays open. You can pass the data over on that open connection without it closing. And then at the end, you do have to close it. If you don't close it, like in the previous videos, by intention, we didn't close it, so it'll automatically reconnect. At least it does on my system. And so if you are actually using something like OpenAPI or Anthropic or one of these paid APIs, you could use up a lot of your resources just in testing. So we'll try it again with UV-corn. And the connection was already open because the tab was open. But let's see. Oh, it's working. We have the response from the LLM, which is local. It's Ollama. There's no cost here. And if you look at what's being sent to us, it's a response. So we didn't specify that the LLM respond as a stream. We're going to do that in the next video. You could process this with a for loop, but we're not going to cover that right now. Also, going directly to the AI endpoint, you can see that it's updating directly here too. And that's because the browsers all support SSE nowadays, and they have for a while. I think if you're not familiar with SSE, it's become more popular recently due to the use with LLMs. Congratulations and thanks for joining me. Hope you had fun. This is the third video in the series. In the next video, which I'm working on, I'm going to cover the LLM set to respond as a stream. So we'll get the tokens from the chunks from the LLM and put it to the screen as it comes in. So that will give you the experience similar to ChatGPT, where it's coming out one word at a time.